Oh, that's excellent. All right. Well, the video is not playing for some reason. So let's move on. This is VUC. Well, at least there's a prompt here. 7378. I swear this is not planned, right?
Oh my God, Randy.
All right. Well,
Good afternoon.
no, this is not my fault. Let's go with this first of all.
This call may be recorded to play at our Christmas staff party.
And from there, just mention very quickly, Coming to Your World, Berlin, Germany, May 6th to 8th. You're going to see the great bag that they give away. And I'm going to switch my camera over. It's funny, every once in a while, Cam Twist will do that. So I am not responsible. Hey, here we are. We were talking just offline a minute ago, and Michael's got some interesting things that will be delivered maybe while we're talking here even, Michael. But let's talk
pull
about
up the security camera.
Yeah, we might even see it delivered while you're talking about it. So what do you got going there?
Well, here's the thing. It's a clandestine thing.
Yeah.
It's my attempt to infiltrate a large organization without the help of Jeff Bezos or any Russians. So we have, and I'm going to call this up. I'm actually going to call this up here. Hang on. I need to get rid of that. I do some volunteer work with the rodeo in Houston every year. And it is the nature of this work that I go and basically act like what so many people did in college. I go and I act as a server and an all-around kind of helpful guy at a place they call the Wine Garden. And we do this, one, because it gets me out of the house, two, because I have an interest in wine, and three, because everything that's involved in the rodeo is, in fact, a charitable endeavor that goes into scholarships to university students. So, long story. All manner of little things happen down there. One of the things is, because we'll be selling wine, of course, we have a list, and the list is fairly lengthy. And they put this great big list up on the wall on these printed posters. And I think that's pedantic because it's difficult to see at night and in weird lighting circumstances. So I have done two things. One is, once the list is published, I build a little website. And this is kind of clandestine. This is done under the radar from a management point of view. But I give out little business cards that have this URL so that people, rather than turning the lights on their phones to look at a menu in the dark at night, can actually call up the wine list on their phones, which I thought would be kind of cool.
Michael, I hope you have a QR code on those business cards that people can scan.
That's how we do it. That's how we do it. Yes, indeed. And so this is actually this year's wine list, which I built earlier this week. And so it's really simple. I need to dress it up a little bit, but you know, it is what it is. It's me doing something I can do to help the cause. But then he said, I wanted to do something other, where the something other was take this information and, hang on, I got to get back to me. Take this information and do something with it that is not quite that. But I was going to show management how to deploy a digital signage solution. And so the digital signage solution I built is based on a Raspberry Pi. Raspberry Pi with a PoE hat on it, connected to a monitor, and is basically displaying PNG files. And there's a wonderful Raspberry Pi digital signage open source software, basically tiny little Linux distro that just boots up and displays these things. Wonderful. This works great up to a 1080 size display, but given that you would probably want to do this on something on like a 60-inch display in such a circumstance, I wanted to do it at 4K. So what I have ordered is an Asus Tinkerboard. And the Tinkerboard is this little number here. Hang on, looking at the Amazon page, which is a $60 little upgraded version in the Raspberry Pi form factor, but it's got, you know, several times the compute power, can drive a 4K display all day long, has a little more memory, costs about $60. So that's what I'm expecting, and I'm going to play with that hooked up to a 4K display. What I'll probably end up doing in the way of showing management is just putting it in a little case, not unlike this one, which is a Raspberry Pi case. In this particular case, it's got a digital audio interface with balanced XLR outputs. This is a streaming music player that I use. I will probably do something like this, Velcro it onto the back of a monitor and just waltz the monitor in one day when I'm volunteering on shift, put it there and say, here, let's try this for the day and see what management has to say about that. And if it goes well, then perhaps next year we can deploy a digital signage-based way of displaying the wine list that can be tied to inventory. So as we run out of things, they drop off the list and you don't have people waiting in line to get to the front of some long queue and realize that they can't order what they want to drink. So this is just, yeah, like I say, it's me doing what I do, and maybe nobody cares about it and it falls flat, or maybe it incrementally improves the experience of people down at the rodeo. So
You have
It's very, very cool, Michael. Have you played with a Tinkerboard before?
I have not, and I've only played with Pis, and specifically I got into Pis. Hang on, since we're doing show and tell, I got into Pis because my other stuff was dying. Where my other stuff was, we were very heavily committed to these things. In fact, this one has original branding on it, which you probably can't see. This is a Logitech squeeze box. Actually, this is a Slim Devices squeeze box, which way back in the day, Logitech bought this company. This was a piece of open source hardware and software that streamed music. Mm. They started out being called Slim P3, and this was maybe 2002, 2003. You put this, because MP3 was brand new then, right? And you had these cheesy little players, but you couldn't play it on your traditional stereo. This thing has Wi-Fi, has a fluorescent display on it. It has a really good digital analog conversion stage. You would put it on your network, could play all your music, FLACs, waves, whatever, MP3s, through your traditional stereo. We had like 6 of these. And we had like basically one in every room, one on the front, one for the front porch, one for the backyard. And the software, which was really written in Perl, ran on a little computer, held your library of music, and it could synchronize all these players. So I could have the same thing playing in all these different rooms, or I could break it up by zones. And in Halloween, we could do like zone by zone spooky sounds, which was kind of cool. So, but Logitech abandoned this, walked away from it. It is no more. And lo and behold, the community got together and ported the little player software over to ARM, and now you can deploy them using open source on Raspberry Pis, and that's what this is. So, except this was $300 back in the day. This, all in, with a much higher quality audio stage, is around about $100 all in now. So. Also balanced audio, because I tend to feed small powered monitors like you would have if you were a musician,
Yeah, studio monitor.
You are. Yeah.
Why is the dog that was white a second ago turned all black?
Well, which dog? Julio. Come here, buddy. Come here. Come over here. Come over here. Mr. Julio? He's not black. He's brown.
Mostly white. No?
Mostly white. Got some brown. He's 2.5 now.
Wow.
He was just a pup. You guys saw him when he was just a pup.
Yeah, he was born on VUC738 or something, right?
Yeah, well, I don't know about that. He was born in September 2 and a bit years ago. So anyhow, all these little things, these are great fun. And they're cheap. And the original purpose of the Raspberry Pi was to have a small computer it was affordable to be able to teach kids to code and design hardware. And I think they're more successful than they ever imagined.
I should remind people that we've had Simon Monk on at least twice, I think. And we should probably get him back and see what he's into. But he's big time onto this stuff. There's the Raspberry Pi. What's the other system that everybody has?
Arduino is another one that's quite common.
And he's
so what are you doing with these, Jay? What's your interest in this?
Jay is a
so yeah. Sorry about that. So many things. Number one is I'm creating what I consider to be the next generation collaborative workspace, and that we are calling Desert Blockchain Camps. And it's designed so that we can put all sorts of Raspberry Pis, Tinkerboards, sensors, whatever you want within this space, and set up the lighting, the cameras, the video, the audio, all that stuff so it's optimized. Because all of us are doing these video conferencing, these conferences these days, and they're just not optimized for the network, for the lighting, for the sound, all that stuff. So this space is designed to have that experience. And I'm interested in using the Raspberry Pis. The 3B Plus is what we use. And I have a side question about that, Michael. But this Tinkerboard is very, very interesting. So that's what I'm doing with the Raspberry Pis and Arduinos and so forth, is creating this space that is as open a canvas as possible so that developers, makers, so forth can come in and basically play as much as they want. Does that make sense?
Yeah. So it's I mean, sort of like a maker space of sorts. I mean,
it's like you can think of it, if all goes well, this will be a meshing together of a collaborative workspace plus a trade show plus a Burning Man. That's the idea.
Okay.
So, yeah.
I mean, I like a lot of things about that, and so we're driven by our application, right? We're driven by what we need to do. And coming from my background, I tend to think everything is either some kind of teleproduction or radio production or trade show or graphic thing. So faced with, the kinds of things that we need to do to stage ClueCon or ComCon or whatnot, I'm thinking, well, I need a digital signage solution to put up on the projectors between speakers, but then I need these other things to enable the speakers to do their thing. And then I need to be able to live stream, and I need to be able to send it to other rooms in the same venue. And a lot of it is going to be based on little things. So here's a little tidbit. And I want to spend as little money as possible. Not that the money's not available, but I'd rather keep it in my pocket.
Well, there's some other considerations around that as well. I mean, I definitely appreciate just the pure expense consideration, but also in the camps model that we're building, it's designed to operate outside, and it's designed to operate with a lot of people, coming in and out and going. And so the lower cost provides a level of safety in that if something happens to it, if it's damaged, if somebody steals it, whatever, it's not a big deal. You just swap it out. And also the lower cost means that you can afford to put these things in many more places than if it were an expensive piece of equipment. Does that make sense?
Yeah. Yeah, it does. That does make a certain amount of sense. And that's what I'm talking about, my activities at the rodeo. It's an outside venue. I mean, it's tented, but it's an outside venue, and there are drunk people running around. So you need things to be as robust as they reasonably can, as disposable as they reasonably can. And I just look at the idea of, okay, if a Tinkerboard, if I can run it over power over Ethernet, And if it's a tinker board in a metal case like this, and I can maybe keep the cost to like $100-150. The big cost is the display, and we're going to graph that in. Actually, the biggest cost on a per location basis is the stand and the mount, and which is sort of physical security. Because the display is 60-inch 4K display, you can get a cheap one for $400, but you're going to pay almost that much for the stand if it's something that won't fall over in the wind and whatnot.
Oh yeah, you need a stand. You also need a proper protection in front of the screen. So you need a box to keep it. If it's really outside, you need something that is.
Yeah. Well, these will be under a tent, and I wish I had some pictures to show you, which I really suppose I could dig for them.
Sort of like a gazebo.
Yeah, and in fact, in a lot of cases, there are like 6-foot tall coolers, and they're actually going to be mounted atop the coolers. This is what my vision for this would be. But it's all, like I say, it's my clandestine little thing. So I'm going to do something sometime in the coming month. Just wander in with I probably won't bring a 60-inch monitor, but I'll bring something like that, and just say, hey, show management, how would you like to have these? And then once they're signed off on the idea, then the task becomes finding a sponsor to fund it.
Check if there are any standard compatible VISA mounts for the Raspberry Pi.
Yeah. There are, and that's not a problem. And they run so little power that even if you can't run them PoE, you can take a USB to micro USB cable, and you can run them off a port on the back of the monitor.
Yeah.
Mm. I have a question. That's my side question about the power over Ethernet hat. Is I assume that the Raspberry Pi you have is not a 3B plus.
Yeah, it is.
Or it is. So you still need the power over Ethernet hat with a 3B plus.
Yeah, when they added quote unquote power over Ethernet capability, I'll take it apart so you can see, to the 3B plus, what they really added was a couple of pins on the motherboard. And the pins are there to receive power from the PoE hat once it's extracted it off the network. So it's sort of a bridge.
So, it's a passive PoE. It's not a PoE based on 822 something AF.
No. Not exactly.
Okay.
So I'm hoping that you're going to be able to see this. This is the Raspberry Pi, right? On the 3B plus, these things, these little pins right here, these 4 pins were added. And what those 4 pins do is they receive power from the back side of this PoE hat. So the PoE hat interfaces on the GPIO. That's how it gets access to the network. And it has all the facility for filtering and regulating the power and doing the negotiation of the 802.3 AF. And then it sends the power back on these 4 little pins. So you have to put these 2 guys together. And there's a sad fact to this, and that is this combination somewhat precludes you adding another hat, because it is the hat, and Pis are not designed to receive multiple hats.
What's the difference between hat and daughter board?
HAT is an acronym. It stands for
really
something attachment. Okay. Yeah, it's like
But it's really
it's really a daughter board.
Okay.
And lots of things use the GPIO pin structure, and there are lots of different hats. Witness my digital audio hat, which fits on there too. Now, but you see this hat, the pins go through, but they're just soldered. So when you put this on here, you can no longer PoE it. There is a hack whereby you put something on the GPIO thing. It's like an extender. And then you remove this from here. You have to do a little soldering. And what you end up with are GPIO pins that go through the PoE card and can thus receive an additional hat. And now you've got a PoE capable Raspberry Pi that can take a hat that does your camera processing, or whatever your robotic thing is all about. So
the problem with that design of the GPIO that can only be accessed by one daughter board or one hat is just a stupid oversight that you're not using a pass-through connector, or is it because the GPIO cannot share multiple hats on the same?
Fundamentally, there's a memory space addressing issue.
Okay.
So some things like the PoE hat, which doesn't access memory, it's fine because you won't run into a conflict. But if you were trying to stack up hats, you would very quickly find that you'd run into address conflicts if you were using things that had any kind of DMA.
So what about the Tinker board? Is that can you use the hats that are designed for Raspberry Pi on the Tinker board, or do they have their own set of hats and additional hardware?
Well, the form factor. Actually, hang on. Let's do this with this continuing show and tell here. I'm going to Google this. The form factor is identical, and you really want it to be the same. So if I look at the ASUS website and share that to you guys, which is this way, you can see they go to quite a bit of trouble to mimic the form factor exactly. And I'm not dead certain if everything that works on a Raspberry Pi works on a Tinker board, but I know the Hi-Fi Berry folks say that their digital audio stuff does, and that leads me to believe that it's probably pretty standardized. What the Tinker board has that the Raspberry Pi doesn't, it has a bunch of flash on board, so you don't have to boot it to an SD card, which is nice. And it's got real gigabit networking it's not a hack on a USB interface on the board. It actually can deliver gigabit. It uses a Rock chip processor. A lot of that's driven by cost, right? Has a good GPU.
And it has 2 gig of RAM. Is that correct?
Yeah, and so here, for example, they've already been certified for use by Fuse and IQ Audio and a bunch of things, because it turns out that the minute the Hi-Fi Berry folks came out with their little, which is this little digital audio board. This is like a $25 little board. They sold thousands of them, right? I mean, it was a logical step. Hang on, I'll go back here for a second because this looks interesting. It's a CPU comparison to, so it's just got massively more CPU and GPU than a Raspberry Pi because they're not constrained to that $30 or $35 selling point. If you say, hey, in our market, $50 is fine, or $60, like literally 6 times or 4 or 5 times the GPU.
So does it run Raspbian? The Tinker board?
Well, this I don't know yet. I'm going to find out though. They have their own thing they call Tinker OS, and one presumes it's Debian based, so one presumes that it's just a slightly tweaked version of Raspbian. But we'll find out, right?
Interesting, yeah, because
for $60,
ideally
it's an experiment I'm willing to do.
Ideally, you'd, or at least I would want to run Raspbian so that you've got a consistent OS across the whole thing. I wouldn't want to be messing around with even two versions of Debian. That's for sure. So
well, okay. That being the case, I'm going to do something flagrantly self-promotional here, because you said Raspbian. About 4 days ago, Magpie came out. Now, Magpie is the official magazine of the Raspberry Pi community. They came out with an article in issue number 78 for February. And what does it say? It says, hang on, I'm going to zoom in. Build a telephone exchange with your Raspberry Pi. It's how to use Raspbian, a Raspbian version that's bundled with asterisks to build a little PBX. And I am not ridiculing this, but it is exactly the same, or, well, more or less, the same as something I wrote, I'm not kidding, 13 years ago, which was the thing that got me started in all of this blogging and whatnot anyway. And that was how to build an embedded asterisk server using a Socris Engineering single board computer. And back then, I literally had I had an Astra 480i, as you can see in the picture, and that old KDS monitor, and there you go, right? That was the first VoIP article I ever published. It was written for a site called SmallNet Builder, and it used the very first release of something that was called Asp Linux. And we've had, well, Derek Hartman was a former regular here, and Christian Kyle Hoffner has appeared. They're the fundamental authors on that. So this was 13 years ago last month. So I'm like, hey, what goes around comes around. Just slightly ahead of our time.
That is funny. We did a lot of that stuff back in the day. Yeah, 13 years. We've been around that long. That was our first year on this thing. You were blogging right before then, though, I think.
I started blogging late in 2007.
Right.
Right, and it wasn't that long before I discovered you, or y'all, as we say.
Y'all, yeah. We should probably mention that DSL reports was a thing, still is a thing, but it was pretty popular then, and people got on and talked about Free Will Network and all of the rest of the things that were going on at the time. So it's funny. The world was small then, Michael. I mean, the folks we know and everybody we meet at Camellia World or the UK thing or any of that, most of them were around then. James, by the way, I don't know what's happened to James. He hasn't been around in weeks.
Speaking of James, I have a question for you all. And I accept that none of y'all are medical. None of y'all are MDs or RF engineers or whatnot. But I have this question that came up. Somebody pointed me to something, and I'm wondering if an intercession is required. Somebody went to Houston City Council this week and pitched, they talked to the council. It was a journalist for our local PBS station, young man, seemed nice enough. But the city has tried to promote to the telcos 5G wireless network rollout. In fact, they had some official thing where the first 5G client in Houston was a sort of press release event last week. I don't know whether it was Verizon or AT&T, but whatever. It's probably Verizon because they've been doing physical installs. But what this young man was saying was, hang on, while the city is trying to position itself to have a strategic advantage by being an early 5G market, he was saying millimeter RF technology is a health hazard. And he was pointing to a bunch of studies. And what I'm trying to understand is this just the people in the tinfoil hats raising their profile, or if there's any real, like people being allergic to Wi-Fi, which I've heard of more in the UK than any place else. In London, there are buildings, like apartment buildings or condo buildings, right, where they are certified Wi-Fi free. And if you're allergic to Wi-Fi, they command a higher price because they're Wi-Fi free.
I actually, when we lived in Paris, there was a woman on the top floor who claimed that she felt something from the Wi-Fi. I wanted to do a test. We were friendly with her, and she was a very nice person. And I asked her to come into our place, and I said, I'll turn the Wi-Fi on and off, and you can tell me, we were going to do the test, but she never did it. So I don't know, whatever that means. She moved, and she moved to a zone where there wasn't any Wi-Fi. But Michael, I don't know where I saw this, but I did see an article or some kind of blurb about this very thing. And I don't know, no one knows really what it means yet, because frankly, what is 5G?
Well,
We don't really know what it is.
Point.
What his presentation was, his presentation referred specifically to millimeter wavelength, which suggests that he's speaking about specific frequency bands, and he was characterizing it as having a maximum transmission distance on the order of several hundred feet. So he's probably talking about the 60 gigahertz band, or maybe a 30 gigahertz band. But 5G, and James is fond of saying this, is, he talks about the RF waveform. Well, it's an encoding scheme that can be applied across different spectrum, right? And so, particularly with all these software-defined radios now, they're all frequency agile, so that some people will deploy them at 5 gigahertz, some people will deploy them at 30 gigahertz or 60 gigahertz. The applications will be different.
Right.
But the question is, does a 60 gigahertz, which has existed for a while, by the way, because they used to call it ultra wideband, and it was used for wireless displays. Does that, it doesn't penetrate anything.
Well,
they say that it interferes with cellular structures.
Okay, what I was talking about, and what many people talk about, is Wi-Fi, which means you have Wi-Fi in your house, and the router is radiating, and that disturbed that person I was describing. However, if you're talking about cell phone towers, then the 5G. Somebody's got.
Not me.
Sorry, it was me.
Wi-Fi is very pointed, right? Wi-Fi is in the 2.4 gig range.
Yeah, or the 5
gig range.
Yeah. Do you know what is the frequency of a standard microwave oven?
2.4 gigahertz.
2.4. And why?
Because it's absorbed by water.
Exactly, because it's the frequency at what the H2O molecules vibrate.
Take a look at what this article says. What is 5G? Mind-blowing data capacities, blah, blah, blah. All right, 1G, 2G, 3G.
But look, he says specifically higher than 1 gigahertz, higher than 1 gigabits per second, okay, for data. He doesn't actually talk about the RF spectrum.
Yeah, that's what's important, is the RF.
The RF spectrum is different country by country. You know that mobile phones work on different frequencies in the US and in Europe and in Japan and in Korea and so on. So the technology to convey the communication, the protocol that goes on to transfer data is not the carrier, where it's a different ISO SI level we are talking about here. The damage that can be made to different molecules of our fundamental elements in our bodies depend on their resonance frequency.
Frequency and strength.
And the strength, of course.
And also duration of exposure, and there's all these things.
Yeah, not just the duration, but the overall during your life, how much you've been exposed, how much that damages your tissues and so on. But do you know what happens to astronauts that are outside the ISS if they don't have proper shielding?
That's gamma rays, though, no?
That's because they're outside the neutrinos. That's because they're outside the Van Allen belts.
Right? Exactly. No, they see neutrinos that are hitting their retina. They see flashes in the eyes because neutrinos are hitting the retina. Oh. But neutrinos are going through our atmosphere anyway. There are some research labs that have to go deep underground, under mountains, to stop neutrinos to interfere with their measurements. So we're bombarded by neutrinos every single day of our lives. That's an example of a type of radiation and particle that is hitting us. There are radiations much stronger that are in the environment, that has been in the environment forever. Gravity, for one, the Earth magnetism that have always been there. And I don't believe that our bodies can be so sensitive to specific frequencies. It's the resonant frequency of the molecules that are in our body that probably we need to look at. But so high up, I don't think there's anything that can resonate at that frequency.
There's already
well, and so the real question is, it's one thing to say, hey, we should look at this. It's another thing to say that, I feel ill when my DECT phone is on. And so I'm just wondering, I'm wondering if, this gentleman is literally, when you go to city council, you're speaking to a bunch of profoundly underinformed people, right? Yeah. About what is essentially a medical research topic. And so do we put the brakes on something that's already in the middle of rolling out and say, well, because what the medical community is going to do is want 5 or 10 years to look into it.
Right? Just take a look at this one. This is one of these panic sites. I'm just curious. We could take a look at. It's easy to understand. It says 5G cell towers are more dangerous than other cell towers for 2 main reasons. First of all, it's ultra high frequency and ultra high intensity. 3G and 4G. No. Yeah, well, wait a minute. Let me finish the sentence and then we can tear it apart. 3G and 4G use between 1 and 4 gigahertz frequency. 5G uses between 24 and 90 gigahertz frequency. Put this in perspective, 90, but whatever, blah, blah, blah. This is a whole lot more radiation that we're exposed to. Well, the frequency, yeah, I'm telling you, the frequency
from strength.
Yeah, it isn't more radiation because it's higher in frequency.
No.
But anyway, the point is,
it's decibels that
already count. Right. But there is already. Let me go back to this list. When you do a search, there's already tons of. Oh my God, the dangers! Look at this. Most dangerous technologies. 5G radiation dangers, must watch, scariest 3.5 minutes ever. Oh, that's going to be good. Let's take a quick look at this just to see and get a laugh.
This is the thing, though, is there's a lot of fear mongering that happens on the internet. The internet may well have been designed for that purpose.
Yeah.
So I just wonder how serious one can be.
Take a quick look. Plagiarize their thing. Therefore, harmful to all living organisms.
Higher frequency is ionizing. What? This
is ridiculous.
Scientist in me is screaming now. It's
beyond insanity. Corrado, it's beyond insanity.
Yes.
High frequency radiation. All right, anyway, enough of that.
Okay. An ionizing frequency is the frequency at what a molecule resonates. And depends from the chemical element of the molecule. That's the ionizing frequency.
I don't know. Look, let's face it. The other thing is that tests need to be done, and I'm sure somebody is doing.
I think there's a lot of fear mongering because it's clickbait, first of all.
Yeah.
And because it's, I don't know, narcissism. Look at me, look at me, look at me. And there is a lot of confusion in terms, not knowing exactly what a term defines, like gigahertz is power, and the larger number is larger, stronger power. When it in effect is always the opposite. Hey, James is with us.
James is with us to answer your question about 5G, Michael.
But lower frequencies require higher power to be transmitted, and they're usually used at higher power.
So do you think when I was listening to the BBC on long wave, I was sterilized?
Well, if you were near a long wave broadcasting station, in particular environmental conditions, you could see dancing, shimmering on the wires, and they were practically synchronized with the music. You could hear the sound of the music on the aerial from there.
But we do know that, seriously, that standing in front of, say, a big radar dish has the possibility of sterilizing a man. But
because it's a high power concentrated radiation. That's how the microwave oven has been invented, because someone felt heat coming from the dish of a radar.
Someone was a radar engineer working for Westinghouse in the Baltimore, Maryland area, who noticed that when he was running his experiments, was melting the chocolate bars that he had with his lunch.
Right.
And
So
I actually know somebody who worked with that gentleman.
quick question for James, since he's joined us. James, would you be willing to give us your definition of 5G?
Yeah, okay. People keep on thinking that 5G is just about going faster, but it's not. 5G is all about being able to trade off between three different axes. So one of those axes actually is speed, and with 5G waveforms, because 5G is all about introducing new radio waveforms mainly, you can go extremely fast, but you may not just want to go extremely fast for in many scenarios. So it's all about trading off between speed against latency. So you might have an application which wants ultra low latency. An example of that could be driving a car or flying a drone, or even doing anything like gaming or telesurgery, anything where you've got, or playing music. Randy, there's one for you. So for those scenarios, you want ultra low latency, and that doesn't sit well with super fast, stuff it down the pipe as fast as you can type mode. And then the third axis, this one's my three orthogonal axes. The third axis is to do with power and range. So
Distance.
Some applications, you want to be able to either work over a very, very large path loss, or you want to wind the power down at the outstation so that you can do something like running a 5G IoT device on one single battery for 10 years without having to replace the battery. So it's still the same axis. It's the power axis.
So what do you think of this?
Yeah, what's all that about then?
5G insanity.
So yeah, there is something which is significant there, is that that third bullet point, massive deployment of towers. So typically as I think Corrado mentioned, in order to facilitate or to deploy 5G, you've really got to go up in frequency in most cases, which means that the size of the cell is going to shrink, which means that in order to cover the ground, you need many more of them. So with 2G, 3G, 4G, the big network operators have been able to get away with just lobbing new radios onto their existing towers. With 5G, you really won't be able to do that. So we're faced with the challenge of finding or having to deploy 100 times more cells to cover the ground. And the only way that you can do that effectively is by allowing private people, to run their own radio infrastructure. A bit like your Wi-Fi access points.
So is 5G a combination of software and hardware deployment? It sounds like it's really basically just a mesh network to me.
5G is not one thing, it's a family of things. So at one end, you actually are going to have big towers with big multiple antennas, so MIMO antennas, so 2448 antennas in phased arrays, which gives you hugely better performance and the ability to beam up very precisely on endpoints to give you the performance. But then you will also have at the bottom end, tiny little base stations like that, which you'll have in your house. So it's all 5G, but it's just different parts of the 5G constellation, if that makes sense.
So we will have a tower with a point to multi-point and then little repeaters.
Yeah, you'll probably have something which looks remarkably like a wireless access point, if not even built into your wireless access point. But the difference between Wi-Fi and 5G is that the 5G stuff, firstly, it'll have a much more robust waveform than normal Wi-Fi. Secondly, it's going to have a much more advanced authentication and sort of cryptographic protection, which means that somebody with a mobile phone from outside will be able to come in and just attach themselves to your network. But it won't be your network because it'll be a network slice.
James, you weren't here when this came up, but we were talking a little bit about people who claim to be or are sensitive to Wi-Fi frequency. I'm just curious what your take is on this. I mentioned that.
Yeah, well, I'm very good at making tin hats.
I had a neighbor. I just want to say I had a neighbor who claimed to be sensitive to this, and she was very, very sincere in it, but she wouldn't do the test when I asked her to come over, and I told her I would turn the Wi-Fi off and on, and she could tell me whether she felt it or not. She did move out. I mean, she wasn't kidding, and I sympathize with people who have this, whether it's an illusion or not, because they do suffer. But what's your take on that? I mean, Wi-Fi is infinitesimally small signal, right?
Yeah, it's very low. 200 milliwatts, something like that.
And again, James, is not the power at the aerial, but the dB strength that hits you.
Yeah, absolutely right. And when people get upset about mobile phone masts and things like that, they don't realize that the bit that is more likely to cause you damage is not the mast, but it's this bit, because this is the bit that you tend to clamp to your head.
I think actually the texting part is what will kill you.
Texting?
If you're behind the wheel. Or something.
Nothing to do with radiation.
No, not. It doesn't.
Well, to be fair, the antennas are always on the other side of the mobile phone. So the screen is here. There's
so the antenna is at least a centimeter away from your head.
Yeah.
But
well, you know the concept of a Faraday cage, and there is metal between one bit and the other.
It's all about power density. So my solution to that problem is that you just have lots and lots of little cells. Like every school classroom should have its own cell to protect the children. Because when you've got a local cell, the handset winds down the power. It doesn't have to shout anymore.
Exactly.
So people with the tinfoil hats, though, look upon that as being every school classroom has its own cell specifically to nuke those children.
Is it better a 20-watt, 5 gigahertz mast that is beaming across a building, or a tiny 0.2 milliwatt aerial in every room?
It's like the difference between Wi-Fi and the difference between Bluetooth, isn't it? Bluetooth is very, very low power, limited range, and Wi-Fi is a little more powerful, has more range.
Yeah, but don't forget, this system has got two ends, and it's the end that has to shout back to the base station that's clamped against your ear. So, a low power cell very close in is going to be very good news to you, because you don't irradiate your head and your battery lasts longer.
Exactly. It's the old chestnut I had a gripe with about some adverts on TV, the most powerful Wi-Fi, and the guy was up in a helicopter. The Wi-Fi signal was there. Yes, possibly from the station to the handset or the tablet, the signal can go up there, but can the tablet then beam back to the base station at that distance? Either it gets scalding hot, the battery runs out in 2 hours, or it can't because it doesn't have enough power to go back to the base station, to the wireless router. So complete bollocks.
It's an interesting point. What is the relationship between the transmit power of a Wi-Fi device, which I suppose varies with the device, right? And what it can receive? Because if you look on your whatever device you have, whatever phone you have or tablet. Oh, an invader. Okay. She's going to get wine for the mussels. White wine.
White wine.
I see.
That reminds me, Randy, you just reminded me. You know where I was last week, this time last week?
No.
I was on my way to Brussels for the mussels.
Oh, well, that's
I was with Dan Jenkins in his Tesla, driving through the Channel Tunnel in order to go to Brussels, where I had a number of meetings. And the reason I'm here now, have you talked about IPFS yet?
no, not yet.
Okay, because one of the reasons I was going to Brussels, to FOSDEM, was to meet with David Diaz, who is, I guess, the father of IPFS.
And why isn't he with you now on this podcast or whatever you want to call it?
Well, he's a busy bloke, isn't he?
Ah, well, I don't know.
Anyway.
Actually, Juan Benet is the father of IPFS, the founder of IPFS.
Well,
but David Diaz is their chief engineer for the JavaScript version of IPFS.
Funny that men are always anxious to be the father of some technology, but the children's different story, right?
Yeah, well, I think David is the guy who actually took the dream and made it real, isn't he? That's his role.
Anyway, we're anxious to have somebody on from there, and I'm happy to have that happen whenever it does.
Right.
Who else did you see at FOSDEM? By the way,
all the usual people.
Well, wait. Did you see the gentleman that we had on who did? Oh, no, I can't remember. Jump. You know, Mr. Denver Gingrich. Did you see those folks?
No, but I saw Mad Dog was running around the place.
Mad Dog?
Mad Dog.
Mad Dog?
Yeah, Beard. John.
Mad Dog Hall.
Yeah, him. Yes. I bumped into him.
From the Linux Foundation.
Yeah. So Daniel was there. Kama people in depth. Lots of XMPP people. Matthew from Matrix. Matthew from Matrix did the most amazing presentation in the massive lecture hall, where he'd lost his voice, but that didn't stop him, and he actually built in a live dangerous demo in the middle of it as well, and got away with it. And it was live because I managed to send him 2 messages whilst he was demoing. Very, very impressive. And loads of other people as well. I mean, just so many other people. Too many to mention. And you can't take 2 steps without bumping into somebody outrageous that you know. And then we had a brilliant dinner, which was organised by Tori from Boxbone, which was.
I'm surprised you didn't come back with something. Did you bring back some goodies or some gizmos?
Maybe.
Come on, show and tell.
Well, I was sitting down in a cafe and this bloke said, and we were talking about SIM cards and things, and he said, well, you might like one of these, and gave me this tiny little chippy thing. And it was a USB-based computer, or FPGA, so which you can program to do all kinds of things. Principally, I suppose one of the principal uses is to do cryptographic things. So you run all your key crypto generation and distribution security bits on this FPGA thing. The guy just said, "Here, have one of these," and I just looked it up this afternoon because I managed to drop it in on the floor of Dan's car, and he found it yesterday. And they're $45 for early bird on crowdsource, going up, I don't know, $55 later or something like that. And I managed to drop it on Dan's car floor, which is annoying, isn't it? But yeah, there were a whole load of all the other gizzits, which I'm not even going to mention because they're all so boring.
Well, having said that, we have a flood next door in the garage that I need to tend to.
Really?
It's 1855. James?
I only came in to talk about IPFS. I want to hear what has to be said about IPFS and what's going down and what's exciting, because we've got some really good ideas.
So I'll jump in on that because I'm actually, as soon as I hang out from this session, I'm headed down to the the Arizona State University Law School, where I'm going to be part of a hackathon, a legal hackathon, and we're going to be focusing on IPFS as a new way to manage legal records, as well as to do peer-to-peer encryption of legal records. And so that's an area that I'm very, very interested in.
Okay, well, the bit that interests me is how you do your key management, and in particular, how you deal with scenarios like what you do when you lose your keys.
So the opportunity set with that, particularly in the legal realm, is to do like a 2 out of 3 signing of the keys or management of the keys. And so you can imagine where you've got basically like a trustee that can restore your keys or act on your behalf.
Yeah, multiple factors. It's the way.
Yeah.
Definitely.
They call it multi-signature, but that I think is workable when you've got very important documents or whatever. And if I'm incapacitated, basically one of my loved ones plus an attorney can act on my behalf, if that makes sense.
Yes, that makes total sense. And that's one of the big issues that we've got with first generation cryptocurrencies like Bitcoin, which is that there really is no way of recovering your assets if you lose your keys.
Exactly.
There was a story just this week in Canada that there was a cryptocurrency that the creator of it held the only reference keys, and he died. And some people in Edmonton lost like $20 million, and they're petitioning the government to get their money back. And it's looking like they will. But what it says is that these things which are supposed to be trustless are not, in fact, trustless.
Well, there has to be a balance for this to really work and to be scaled up between the vision of, hey, it's completely trustless and I control everything, with the fact that, hey, we're all human and we make mistakes, and there's certain times when we need other people to act on our behalf, and we do need to have trust outside of this mathematical construct that we're talking about, that I hate to say it, but Randy will take a drink, called blockchain. So anyway. So I have to go, all, and thank you so much. This is very, very informative for me. And Michael, I'm really looking forward to hearing how your Tinkerboard project goes, because I'm sure I will be experimenting with Tinkerboards as well. So cool.
Yeah,
watch this space.
I look forward to talking to you at greater length. I'm so flipping busy at the moment. I've got so many things to do.
Yeah, there are some very, very interesting things that you can do with IPFS and related tangents from IPFS, and David Diaz is definitely somebody that we should have on here and talk about some of the WebRTC and communication possibilities. I actually saw a live stream demonstration on the all hands call where this group out of San Francisco that's into mesh networking was actually doing live streaming directly through the IPFS protocol. That was very, very exciting. So anyway.
Well, I'll tell you what, I've got access to his live diary. So if and I need to set up a session with him. So if I set up a session for him for a week's time, and then if we're lucky, we can probably convince him to come on and do a short session here on the VUC, whatever it's called now.
That would be very cool. I'll be happy to ping him as well, James. So
cool. We can aim to do that. Oh, awesome. By the way, Hank was in Brussels as well, and I didn't realise it.
You didn't meet him?
Well, no, he pinged me afterwards and said, "Hey, I didn't realise that, but you've been in Brussels."
All righty.
Catch you later, Jay.
If you want to wait just 1 second, you can see this digital signage thing boot. But
you can wait.
And by the way,
garage floods.
Michael, on the way back from Brussels, Dan and I were discussing all the people who really ought to be at ComCon, and your name was on that list. Ooh, crikey, what's that?
Is Rob thinking of sponsoring anybody? Because
yeah, well, Rob was there. You probably saw the photo. He was there. In fact, he was the guy who introduced Matthew Hodgson in the big thing. He was actually working.
But do you think he's going to do sponsoring people again? Because that's how I got there.
Don't know. Possibly.
Okay. Well, with that, I think we need to go over to I need to get into flood mode and start.
Oh, there you go.
I had a notification.
Oh, here we go. Right, we were waiting for this. Sorry, wait a minute.
I had a notification that flights to and from Bordeaux are super cheap this week.
Good. Come on over. So what are we looking at?
Well, this is a really boring presentation of the wine list for the Rodeo Wine Garden that's coming up, and the sign is designed to be shown portrait mode, so it's on its side here, but it's basically just hang on, I'll come back to me. What you're actually seeing is the Raspberry Pi plugged into an HDMI capture device, so that's its output. And just a second, and I am like, oops, not that one. Not that one. Not that one. What did I do? There, I am here. So you're seeing the Raspberry Pi output this signage at 1080p dynamically, and it's just sort of cycling between two displays every so many seconds. As if it's still working. I think it is. Yeah, there it goes. Which is just a default thing. I have to pretty up the displays, of course. That was just done in PowerPoint, but hey, for a $35 little solution, it's not bad. And so imagine, if you will, you're at ComCon, and this is displaying the thing that was behind the presenter, right? Because there was a giant monitor behind on the back of the stage, right? And it has to be something that does that. And so that's what that is.
Well, that's why you have to come, I guess.
This is why you have to be.
Dan pinged me on wire about that. We're talking.
Okay, great.
Good.
So,
yeah, because we decided that you really, really do need to be there.
And with that,
and you as well. Oh,